Alright, so we're going to be going over the practice problems, the Unit 3 exam practice problems that are from yesterday. I'm not going to spend time reading the problem. I'll put it up here, and then I'm just going to walk through quickly how to do it. I'm not going to, I'll explain a little as I go. But I would recommend watching this again at home if you miss something, and so you can pause it and everything there. Okay, so here's number one. So what we're given is a resultant vector, and we're asked to determine the components of this resultant vector. So I'm going to draw the resultant vector first, making sure I pay attention to this this direction here that is south of west rather than the usual counterclockwise of east. Alright, so there's my vector in the south of west direction. It is 2.554 kilometers long. So now what I need to do is determine the components of this resultant. So I'm going to do down and over. So I want to know A and B, and I'm given C. I have just fully accepted the fact that you're going to hear little kid sounds sometimes in my videos, so if it bothers you, you can, put it in the suggestion box. Sorry. Okay, so what we are going to do, how are we going to do this? We are given, I forgot to draw one thing here on my diagram. I am 32.5 degrees south of west, so that means that if I drew a line here from my west and east, that means this angle, or I could draw it right here, but it's tiny, it's easier to see if I draw it big out there. This angle is 32.5 degrees. So in order to figure out what this angle inside the triangle, this theta is, we have to take 32.5 away from 90. And I find that my theta in there is 57.5 degrees. Okay, so now I have all of the information that I need in order to find the magnitude of my two vector components. So what I'm going to do is I'm going to use the trigonometric method. Make this a little thicker. I am going to do sine of 57.5 degrees is equal to the opposite, which is B, over the hypotenuse, which is 2.554. Plugging in, rearranging first and then plugging in, I find that B is equal to 2.15. And then I'm going to do cosine for A in order to solve for the magnitude of that. So here I'm going to do the cosine of this angle, theta. Theta is equal to the adjacent divided by the hypotenuse. And when I rearrange for that and solve, I find that A is equal to 1.37 kilometers. So we have 1.37 kilometers here. All right, so the way that I would report this answer is I would say that the horizontal or westward component of the animal, or of the dog's component, oh, that was spelled right, jeez, I'm going crazy, of the dog's resultant vector, RV, I'm just gonna abbreviate so I can get through this, the dog's resultant vector is 2.15 kilometers, and then you would say the southern component, or the vertical component of the dog's resultant vector is 1.37. So that's how you would report that entire answer. All right, moving on to number 2. So what we're going to do here is we're going to draw out each of these vectors as his motion, or the way that he would have moved. So you have to pay attention here. I was trying to be tricky, and I probably got some of you. So all of these are in different directions. They're not all just counterclockwise of east. So we have to be careful about what we're looking at here. So first movement, 340 centimeters counterclockwise of east at 355 degrees counterclockwise of east. So that's going to look something like this. And we're going to say this is 340 centimeters. And then I'm going to do different colors for each of these. So that's 355 degrees. I'll indicate that even. Well, no, I'll indicate it afterwards. All right, that's 355 degrees counterclockwise of east for 340 centimeters. Then we're going to go directly east. And it's going to test my ability to draw a perfectly straight eastern line. I'm going to try to draw it a little bit more to scale because this is about a third of that. So this is 100 centimeters directly east. This is our only horizontal vector that we have. Okay, then we have 244 centimeters, 75 degrees east of south. All right, east of south. So 75 degrees east of south is going to be somewhere kind of right about, I don't know, that's a little too down, I guess. Somewhere like, no, I cannot draw straight lines. It's terrible. Whatever. That's way too southern, but we're going to call this 244 centimeters cm. All right, then finally, last one we'll do in purple. 62 centimeters, 99 degrees south of west. 99 degrees south of west. So that's going to be something kind of like, oh, and it's a short one, little short guy. And this is 62 centimeters. Okay. Those angles are far from perfect. I know that they're not exactly, that's probably too close to east to be 999. But anyway, you get, we're gonna just call it good like that. Okay, so what we're going to do here, what are we supposed to do? We're supposed to use this information in the table to determine the magnitude and the direction of the injected rat's overall displacement. So we're gonna start here, and we're gonna find our R value, which is ending right here. So this is R. So in order to do this, we only have one horizontal component, and we have to turn all of these other three into vertical and horizontal components. So the way we're going to do that is we're going to make them all into their vector components. This is A, this is B. Whoops, I just wrote AA. Then we're going to do same thing with the green one over here. We're going to do this way and then this way. And we have A and B there. And then finally, we're going to do the same thing with our purple guy. Like that. Okay, so here we have drawn our 3 triangles. And now we're going to find, I'm going to draw these differently. And we're going to find the magnitude of all 3 of these. Or I guess all 6 of these vectors. Because we need to find the horizontal components of each so that we can add it to our already there, the horizontal component we already have. And we need to find each of our vertical components so that we can add all of them together so we can find our resultant. So we are going to start up here with our red triangle. So we're going to draw this vertical or horizontal, this vertical, and then like that. And this is going to be 340. And we have a little angle here, right here, this angle we know, because we know that this whole thing was 355 degrees counterclockwise of east, right? That's what it said in the table, 355 counterclockwise of east. Therefore, this little guy here is going to be 5 degrees. Because there are 360 degrees in a circle, and you already know why. All right, so here we're going to find A and B, all right? So let's, or we could even call this, this would be our X, and this would be our Y, right? Just in case you were getting confused. I'm just going to call them A and B here. All right, we're going to use the trigonometric method first in order to solve for those magnitudes of both A and B. So same thing, we're going to use the sine function and the cosine function like we did in the previous problem. All right, and here you have it. I have solved for my two vector components for my red vector there. So I'm going to put those in. For, B, I had 30 kilometers. For A, I had 339 kilometers. All right, and now I'm just going to do the exact same thing with the green one and the purple one. And rather than making you sit through the exact same thing 2 more times, I'm just going to put it up here on the board. So there are our answers for the green one. If you want to rewatch this at home and check your answers and make sure you got all the right information, you can do that. But here, and then I'm gonna make this smaller here. And I just realized I wrote all of those in kilometers, so I just really quickly changed all of that to centimeters. My bad. Okay, now let's do the last one. We have our 62 centimeters, 99 degrees south of west. Okay, there we go. There are all of our answers for, or all of our horizontal and our vertical vectors for the 3 angled vectors that are part of this problem. So now what we need to do is we need to add them all together. Add all of the horizontal vectors together, add all of the vertical vectors together. So we are going to start with the horizontal. So I have first 339 centimeters from the red. Then I have 236 centimeters from the green. Then I had blue first, but it doesn't matter which order we add them in, so where we put them together. So I'm going to not forget my 100 centimeter blue from above. And then finally we have 9.7 in purple. 9, that's way too not in scale, but there we go. Okay. And I'm probably going to run out of room here, so I'm going to make that a little, well, I'll move it over. Anyway, so we have our horizontal components all added together. So I'm going to add them. They're not added together yet. I'm going to add them all together and figure out how long this line is in centimeters. And when I do that, I find that this horizontal component, this whole thing, is 685 centimeters. 685 centimeters. All right, so I can get rid of that guy, and I can now determine my vertical components. So I'm just going to move that over here so we remember what we did. All right, now I'm going to find my vertical length. So then finally I can figure out my resultant. Okay. So I'm going to add all of the vertical components together. I have 30 in red, 30 centimeters. In green, I have 63 centimeters, 63. And in purple, I have 61 centimeters, 61 centimeters. All right, when I add all of those up, I get 154 centimeters. All right, so now finally I'm ready to determine my resultant, which is right like that. So now I'm ready to determine R. So in order to do that, of course, I'm going to use Pythagorean's theorem first. This is A, B, and C. I'm going to use that, or those values, to find R. And I find that R is equal to 702 centimeters, 702 centimeters. You can look at my math if you are not understanding how I got that. And then what we're going to do is we need to find our theta here. We need to know theta, and to do that, we are going to use the trigonometric method. In this case, I'm just going to use the sine function. And when I do that, I find that theta here is equal to 12.7 degrees. So the way we're going to give this answer is you would say that the resultant vector of the rat, whatever it is, I can't remember, rat, is 702 degrees in the, you could say the south of east, 12.7 degrees in the south of east direction. Or if you wanted to, you could say, we could figure out what this angle is here. And that is 347.3 degrees. So you could say the mouse's resultant displacement is 702 centimeters, 347.3 degrees counterclockwise of east. All right, moving on to the final problem here. So we have two different things here. We're going to first determine the resultant force of the machine, and then we're going to determine the resultant displacement. So luckily, this machine that I made up only moves in one dimension. So it only moves left, right, up, or down. So we are going to draw all of these movements here. So the first motion, since I'm doing force first, I'm gonna just do my force vectors. So we have our first motion to the left, 550 newtons. Then it moves the box upward. I'm gonna have to move this. Moves the box upward. Moves the box upward with 500 newtons of force. This is 500 newtons. Then it moves the box left again, 100 newtons of force, 100 newtons. Finally, it moves it, two more motions. Upward again, 200 newtons, 200 newtons. And then finally, it moves the box rightward with a distance of 440 newtons. With a force of 440 newtons. 440 newtons. All right, so this one is pretty easy, all because we don't have any angled vectors. So all we have to do is add all of our vertical and add all of our horizontal. So let's do all of our horizontal first. I'm going to make them all red. So we're going to add those all together. So remember we have one in an opposite direction here, so we're going to have to really pay attention to that. So we're going to do 550 this way, plus 100, this is not to scale, this way. Then we're going to go in the opposite direction, 440. So in order to figure out how long this remaining resultant is, or the remaining, how long the vector, the horizontal component is, we have to add 550 plus 100 and then subtract 440. And when we do that, we find that our vector is in this direction, and it is 210 newtons. All right, so that is our horizontal component. Now let's do our purple ones over here, our vertical components. We have 500 plus 200. They're both in the same direction. So what we have to do is just put them in that same direction and add them together. 500 plus 200 is 700. There we go. Now we can solve for our resultant, which is like from here up to here. All right, so now we can solve for our resultant here. All right, and the way we're going to do that is we're going to use Pythagorean's theorem and then the trigonometric method. So we solved for the magnitude. We found that the magnitude of R is 331 newtons. And now if we figure out the direction using the trigonometric method, all right, then we find that theta equals 73 degrees. However, we have to indicate that this is 73 degrees north of west, or if you wanted to give it, if I asked you to give it in the counterclockwise of east convention, which I didn't. So if you said north of west, that's correct. You could have also said 107 degrees counterclockwise of east. Counterclockwise of east. Okay. So there we go. That's it for the 3 practice problems. This is very similar to how your quiz is going to look. If you can do all of the problems on here and you understand how I did them. Oh, we didn't even find the resultant of the displacement. Oh, I forgot resultant displacement. Whoops. All right, I'll do that really quick. I'm not going to... I'm just going to do the exact same one. So we have... Let me just erase these values here. All right, so I had... because they're going to all be in the same direction, and now I'm just going to change the values, and I'm going to I'm going to make them into distance values instead of force values. So first the machine pushes the box leftward for a distance of 5 meters. Then the machine pushes it upward for a distance of 10 meters. I guess they're different scales, aren't they? So, yeah, okay, fine. I'll erase it. All right, first we had 5 meters left, not up, 5 meters left. Then we had 10 meters up, so double that. 10 meters up. Then again, we had 7.2 meters to the left, 7.2 left. Then again, up, we have 3.9. And then finally, we have to the right a distance of 14.2 meters. Alrighty. So what we're going to do is the exact same thing we just did, but our resultant vector is going to look a little bit different here. Maybe not that extreme. It might be a little bit less than that, like right here maybe. That would be probably more accurate. Alright, so that's what our resultant's going to look like. So let's use all of the fun methods that we already know how to do. First, I'm going to add up all of my vertical and horizontal components. So I have 14.2 plus or minus 7.2 minus 5, right? Because those are in opposite directions. So when I put that into the calculator, I get that my horizontal component is 2 centimeters this way. All right. And that's probably too big, but whatever, we'll do a little smaller. 2 centimeters this way. Okay, that's my horizontal, and my vertical is 10 plus 13.9. So we're gonna go, whoops, I gotta move this guy down here. Whoops, no. Move him down. We're gonna go up 13.9. Alrighty, now we are ready to find our resultant from here to there. And I'm going to do that using Pythagorean's theorem and the trigonometric method. Alrighty, so here I have solved using Pythagorean's theorem for r, and then I solved for theta using trigonometric method. And I found that my resultant displacement vector is 14 meters. I had been writing centimeters, so my bad. 14 meters in an 83-degree counterclockwise of east direction. And that is it. Now we are done. Like I was saying before, this is very similar to how your quiz will be. If you can do all of these problems and you understood how to do all of these problems and you understand your mistakes, you will do just fine. Don't forget that your quiz is on Thursday, so tomorrow. So, yep, if you know how to do all this, you're good to go. So you can do the reading that is posted on Google Classroom for the rest of the period, or if you guys decided that you didn't want to watch this video in class, then that's it. Good luck studying, and that's it. Let me know if you have questions. Bye, have a good day.